Hello, this is Learning. This is not Santosh speaking today. Santosh is apartment hunting. We wish him the best. So Jay and I are here. Jay's hosting, and I'm being not Santosh. Our our special guest today is Manthan Gupta. He's a product engineer at Google, and you're also an undergraduate on your final year. So I'm very excited to hear what you're interested in and in the area of system design and architecture and things like that. And
Yeah,
Manthan, you're also a writer, and you recently moved to Hashnode. So I think we can share that in the comments so people can find all your interesting work there. There it is.
Nice.
Okay, what else is there to know about you, Manthan?
yeah. So thanks, Lars and Jay, and not Santosh, to have me on the channel. And it's great to be here, first of all. And just a slight correction that I'm working as a product engineer at Qoohoo, and not Google. So yeah, currently an undergrad, final year from Bennett University, and yeah, I mean I've been uh, like into this system design thing for the past year. I feel so because of my interest, leaning towards it, and that is the main motive that I moved to backend engineering as a whole. So yeah, I've been loving what I've been doing currently. So yeah.
What are you doing your undergraduate in? What's your degree?
Computer science.
Makes sense. Cool. So you said you've been, studying system design in the past year or so, right? But what
Yep.
is systems design for people that don't know, and why is it important that we think about and plan systems, design systems and stuff like that?
Yeah, system. So to start off, like, system design is a very subjective thing. It comes with experience and experience and experience. So someone with the, like, developers could fight upon it, like, this is the best thing, this is the best thing, and we have to talk about it and come to a middle ground about it. So to explain what system design is, in an essence, like, it's a combination of high level design and low level design. To even go deeper into it, high level design is mostly about database architecture, database design, system architecture, and all those kind of things where we decide the high level thing. In low level design, we mostly are working with the code, where we decide how our like code design would look like, and without the logic, obviously. The logic is decided later, but this is the overall. uh, Moving on to why it's important. So as a backend engineer who works in a startup, it is really crucial, because in a startup, like, the company is expecting you to be an individual contributor. So as an individual contributor, you should be able to be working on features end to end, from building system to releasing it to production. So it's very important. But in an MNC, I might be wrong, but you don't get to design systems unless you are, like, a bit experienced in the field, like around 3 to 5 years. I might be wrong, but that is something really natural that comes for a developer, because knowing about system, what you are talking, like, it's a general, I would say, a general talking way, a way of talking to developers, right? So even if you're not a backend engineer, if you are a front end engineer too, you should know about a bit of system design, so that you can communicate efficiently with the team. And just think about it as a whole product as such. But for backend engineer as such, I would say it's a very compulsory thing, mandatory thing, because you have to take the ownership sometimes, always, and build systems end to end.
So is system design only relevant for backend, or is it relevant for designing front-end architecture as well?
Yeah, so just as I mentioned before, right? So system design is a way of talking to developers. It is kind of a language in itself. But like you mentioned, front end front end engineers also should know system design, because it is a way of talking to people, like between the developers efficiently. So obviously not knowing it deeply is all right, but knowing the basics should be I think is mandatory for front end engineers too. But for back end engineers, it is really like a crucial thing, because now uh, even in the MNCs are also have started asking about system design, because that is what they expect, that you come in and start to design the systems. But for someone like a very experienced person, like a principal engineer or a software architect, it is like really mandatory to have a breadth knowledge and in-depth knowledge.
Cool. So you said that, like, typically you gain system design knowledge just from, working in industry, after years of experience and stuff like that. But if someone wants to go in and learn about this kind of stuff without needing to spend 5, 10, 15 years in industry, where would you go to study system design?
Yeah, so this is really a great question, because system design resources are not really well structured anywhere as such. You have to it is like you have to catch them, like so one part is there, one part is there, so it's quite distributed everywhere. So the first starting point would be to start with a book that I also started, is Web Scalability for Startup Engineers. So that is a really great starting book, and move on to reading Designing Data Intensive Application. That is another O'Reilly book that I would say that is great. But obviously you can continue on and subscribe me on Hashnode and Twitter, because I also write system design threads and even blogs. And obviously there are other ways to, like, reading company blogs, because these big companies or even startups have started putting on, like, sharing the knowledge across the developer community. And that really opens your mind to the possibilities, and keeps your interest into the loop.
Makes sense. Totally. Okay, so when it comes to like system design, just trying to figure out how to phrase this question correctly. So like you were talking about like the high level system design, which was your actual architecture, the infrastructure and how it's set up and stuff like that. So does system design help you know when you need to scale certain pieces of your infrastructure, or does it help your infrastructure scale when it's needed to scale because you designed it correctly?
Yeah, so this is a very tricky thing, because you don't have a hard code number there, that like, this is the limit. If you reach there, you have to scale. So like, scaling a system is a very complicated thing if you don't have the knowledge, if you don't have the right knowledge, uh, because it gets tricky, because you don't know where to start and where to end. So, like, monitoring the system, or monitoring the system, the usage of RAM and all those kind of things helps in keeping a check on the system, that what is the usage of RAM. So if it's clocking at 90% or so, it is a sign that you have to start doing something, at least something about the system being overclocking or so. So obviously you won't scale directly, like doing vertical scaling or a horizontal scaling. Obviously that won't be your first step. First step would be to go to your code and try to optimize things, try to see, like, how is your code doing, because writing bad code is not the solution to doing this. Like, you can start doing vertical scaling, you can even do horizontal scaling, but writing bad code is not the basic step should be to write good code. So first looking at your code, and then looking at your DB queries and all those kind of things that helps in optimizing things should be your first step. Then if it, then also if it's overclocking, and then you can move to start planning about horizontally scaling it, where you distribute your system across multiple servers and all those kind of things. And at the same time also vertically scaling for the time, because horizontal scaling requires a lot of experience and expertise in the same. So obviously I won't go into a lot much detail because I get very passionate about this. So obviously that's the
There's a
basic thing.
question, so maybe you can get specific about answering this question then, from VJ.
So so there are so different aspects lexicons to get the breadth. Do you go with the checklist? Yeah, so you can't go with a checklist, right? So just as I said, the resources are very distributed. You just have to start learning yourself. Just as I mentioned, like the books that I mentioned are a very good starting point for you. So when you start reading things, your mind opens to new things, and then you start exploring more things because you see a new term, and then you Google it or try to search about it here and there, and obviously then you multiply your information that you have stored. So there is no checklist as such, because it's like I said, it's a very subjective subject in a whole.
Right. Yeah, that makes sense. I mean, it's the classic, it depends, right?
Yeah.
It's whenever you ask a senior engineer, like, oh, like, what's the right way to do this? It's always, well, it depends on so many different factors, right? So anybody watching, feel free to just shout out questions in the chat. We'll bring them up when there's a moment. So what's for you, or for someone wanting to get into this, what's the process of like thinking about designing a system? Like what steps do you go through if you're like, okay, I have the system and I have say I have some general requirements? What kind of thought process do you go through for design?
So thinking for a system is about asking the right questions to yourself. So if you ask yourself the right questions about the system, like what are the requirements, what type of data am I getting, or am I expecting, or how am I going to store it, what should be the flow, how is the user going to interact, and what type of data am I going to get, uh, is my application a high read application or a high write application? That also decides what type of database you are going to use up. And is this going to be an overkill? What are the number of people, like what are the number of users that is going to this service is going to affect? All these questions, like just as I mentioned, like asking the right questions at the right time is the solution of thinking the system. Because let's suppose you're building for yourself. You don't need to host it, right? So you don't need even a server. You can start from your local host. But if you are thinking like let's suppose you are looking for 200 people interacting with your users. So you will obviously host it on a basic like a Vercel, or I think there are multiple free hosting services. But as you grow, like you have 3,000 4,000 users you're going to affect. So you start going to AWS or Google Cloud Platform and take a server and start building from there. And because from day one, building a robust application is a lot of time wasted on something that you don't know even if it's going to happen. So yeah, I mean, you have to ask yourself the right questions about your requirements.
Yeah, the requirements and the constraints, right? Like a requirement might not be the amount of bandwidth that you're going to need, but you might only ever get 200 people a month on your website.
Yes.
Which, we were talking about this beforehand. You probably don't need Apache Kafka if you're only serving a couple hundred people, right?
Yes.
So definitely something to consider when designing your systems is what are the requirements, and then what are the constraints that you need to work towards. One of the biggest learnings that I've had, I'm a startup co-founder, and you should never be over-engineering your product, because you might be building it for the future, but if you never get to that future because you spent all your money developing a product, then there's no point, right?
Yes.
So build it so it works, and try and do it right to the best of your knowledge at that time. But in this, right back in there with designing systems, take the knowledge you have and do it the right way, but don't overdo it. There's the right way, and then there's the like, I'm Google and I'm doing it the right way. Like,
Yes.
don't build systems like multi-trillion-dollar companies build them. Right?
Yes.
So, unless you have very high aspirations, I don't know. Lars, do you have any questions for Manthan?
I always build for scale, even when it's a hobby, a small side project. It's just a matter of keeping your skills up to date and like training, practicing the skills. So I kind of consider it like that. So always use NX, always use a scalable architecture, just so I can keep myself in the game. No matter if I'm doing like almost a hello world thingy.
Yeah.
Manthan, what do you think about serverless? Things like functions as a service, Firebase functions, and Amazon Lambdas and Azure functions?
Yeah, I think it's a new trend that has been going on for some few years, but it has caught the fire currently. Serverless architecture is the new thing, but obviously everything comes with its pros and cons. So that is something like I found with serverless, that testing gets kind of tricky with it. Obviously, with the whole, because you have to trigger something to test it, because you have to pass on the data, and you have to, like, you're kind of building a pipeline with the whole serverless thing. So testing the whole pipeline end to end gets a bit tricky with that, as compared to when you just have a monolithic structure. You just write some unit tests and patch it up.
Right.
So is there cases where you would suggest to go with like the serverless type system design, or would you always suggest to go with more of the monolith?
No, obviously, with monolith, when you're growing as a company, you have around you want to scale your teams too, right? So you have your engineering team that you have to scale. You won't always have only six of your people working on the same monolithic structure. So so there is no separate segregation of the modules that you have. So there is too many interdependency on teams that are working or collaborating together. So if you have to make one change, you have to ask for three more teams that please do my changes, and it's a lot more of friction that is going on with this. So I think obviously serverless architecture has to come into the picture at some place, and that is something that I would say, like, when you're like, there are more reasons, but the most valid one I would say is when you are trying to scale your engineering teams, because you don't want the interdependency of people on each other, because that causes a lot of friction in moving when you are trying to build features and pushing hard to ship out features.
Yeah, separation of concerns, right? Like,
Yes.
You don't want one thing to affect another thing when they aren't actually concerned with each other. Okay, we have another question in the chat. In enterprises, there are islands of expertise like UI architect, BE architect nowadays. How does it all come together?
Yeah, I mean, it is a simple thing, right? So like a backend architect has to architect the backend system, and the front end architect has to architect about the front end, and it's just a bridge, right? You have to, the front end asks for something, and backend has to deliver it. So if I'm able to understand this question correctly, this is something, so like you are building two separate entities and they're connecting with the whole request response thing. So
Mhm.
I think that is that is how it all comes together, if I'm able to understand the question correctly.
But maybe also through having cross-functional teams where backenders and frontenders are not on separate teams, and they can discuss the impact of a change in the back end, how that might affect the front end and consumers outside of the team.
Yes, yes. So as I mentioned, like when you scale teams for different modules, you can so you have a big feature like a push notification service. So you have a team of 5 people, two front end people and 3 back end. So they are the owner of the whole push notification service, and they kind of the one source of truth if I have to ask about push notification service. And uh, they know everything about it. So whenever there is a new change, I go to them and ask them what's the estimate. So they discuss between themselves and come up with that. So
What are the common pitfalls that you find with people going through learning about system design, if you have seen them?
can you pardon, please?
Yeah, so common things that you see people do when it comes to system design that may not be correct or the right way to go about it, like traps that people fall into.
Yeah, so the main one would be being attracted to all the fancy technologies and straight away using them, not thinking about if that is the right if that is the right thing to do, like over engineering it, using the latest technologies because it feels shiny, right? It feels shiny to everyone to to be pointing at the star or using it. So that is the main, like one of the biggest pitfalls I've seen, uh, because it's better to use something that is more dependable, reliable for the last 10-20 years than to use something that has been up for only 1 or 2 years, because you don't know how it's going to react or even if it's going to fit in your use case.
Mm-hmm. So we should all
Or
be
even
using
if it's
PHP, right? That's what you're saying? Every website on the planet should
and,
be built on PHP?
no, obviously not. I wouldn't be so cruel on anyone.
Yeah, totally fair. Totally fair. I've written PHP a total of probably once in my life, and it's because I was forced to. Okay, so one last question for you. Is there a way that you could escape system design? So like avoid it as a developer?
Hmm. Uh, I don't think you can escape, and you should escape the system design because like I mentioned in the start, right? So it is something you talk with people, like it's a developer language to have. So even if you're a front end engineer, you full stack or even back end, so I think you should be doing system design because it's a good thing to know as a front end engineer too, because it gets easier to communicate and the efficiency of communication goes up for back end because you demand the right things, you say the right things, the friction between the front end and the back end goes down with that.
Mm-hmm.
And obviously for back end, if you are working in a startup, you are looking for individual contributors, and knowing system design is mandatory because without system design you are not you won't be able to design anything, and you will be a liability for the startup because you have to wait for the senior engineer that please design my system. And as a senior engineer, you don't want that, right? Because
Mm-hmm.
you want someone to be able to come up with a solution to you, and not the other way around, because they are already uh, they have their hands full with things. So yeah.
Totally. Awesome. Well, that was really informative for me. Lars, I don't know how experienced you were in system design before, but this is the first time I've heard someone talk about it. So thanks a lot, Manthan. Is there anything that you want to shout out, promote, shameless plug? Hit us with it.
Yeah, I think I would like to promote my Twitter account because I've been very active there, and I post about system design there and write blogs on Hashnode. So these are the two places where you can follow me. I'm very 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 active on Twitter, and if you have any questions other than the one that are asked here, I would love to have a conversation over there.
Awesome. Great. Well, thanks for coming on the show. Hopefully we'll get to have you again on here sometime in the future.
Yeah, definitely. Enjoyed this conversation. Thanks, Jay. Thanks, Lars, for having me.
Nice meeting you, Manthan.
Thank you, everyone, for showing up. Stay tuned for our next episode. I don't know when it is. Lars, do you know when? Oh, it's the 30th of March. We're talking about the Observer Spy library, which
Yeah,
Resnick.
Yeah. So it'll be about testing RxJS observables with the magnificent Shai Resnico.
And the best observable testing library that's ever been written. I'm convinced.
Yeah.
Yeah.
Thank you for now.
Okay. Thanks a lot. Bye, everyone.